Hello there. We have a kinetic energy question. Car P has kinetic energy 240 kilojoules. Car Q has half the mass and twice the speed of car P. What is the kinetic energy of car Q? So this is a standard example of how Cambridge is asking us if the variables are changed given a particular formula, how do you go about it? So first thing first, we need to know that what is the formula for kinetic energy. So generally speaking, kinetic energy of any moving system will be equals to half the mass as well as the speed squared, half mv squared. So right now for car P, the kinetic energy is given as 240 kilojoules. So we can express for car P, it has a mass of mp and a speed of vp. So therefore, plugging into the equation, we can get the term half mp vp squared is actually equivalent to 240 kilojoules. Now, for car Q, okay, for car Q, what happens? It says here, mass of Q is half the mass of P, whereas the speed for Q is double the speed of P. Now we just express the kinetic energy equation for car Q. We can get that EKQ, which is the kinetic energy for car Q, is equivalent to half mq vq squared. So now we want to compare, substituting these two equations, mq in terms of mp and vq in terms of vp, and then we want to compare with what we have already obtained for mp previously. So substitute into our equation, the kinetic energy of q will be half mq is equivalent to half mp, okay, and vq squared is basically equals to 2 vp squared. So we just expand the terms. What we can get is basically, we just preserve the half here because there's a half in the original equation for original expression for EKQ. So half mp, 2 vp squared. If we expand this, we get 4 vp. So 4 vp is basically just 2 mp vp squared. So if you take the 2 out of this equation or out of this expression, so you get 2 half mp vp squared. So we know that half mp vp squared is equivalent to 240 kilojoules. So this you can just substitute 2 times 240 kilojoules. So you get the answer 400 kilojoules as the amount of kinetic energy for car Q, where the answer is C.